Hey guys, welcome to System Design Fight Club. Today we are going to be going over the design for a coding competition platform, also known as the online judge problem. Some examples of this are Codeforces, Leetcode competitions. I think there's some other ones kind of like HackerRank or CodeChef. But we're going to be designing both the part where you can submit the problem and have it graded and the ranking part. And for our specific approach to it, we're not going to have the contestants ranked until the very end of it. I can briefly go over how to have the live ranking updates, but it seems like the way that I'm going to be designing this most closely to the way that Leetcode does coding competitions. And for them, it seems like the full ranking doesn't actually really get put out until kind of like a day or like a couple hours after it actually ends. It kind of like updates them for a couple of hours following the competition, and then it has like a proper ranking, and then it doesn't update your ELO ranking until like Wednesday. So we're not really going to have that running live, but I can briefly discuss that. We want to focus on the submission part for what we're going to cover. Requirements, we're going to take submissions from the contestants. We're going to evaluate whether or not they are successful or whether they've failed some of the unit tests. And then we're going to have ranking, but that's going to be all the way at the end of the contest when it ends. The numbers we're going to be dealing with is I'm just going off of Leetcode's numbers. So those ones have a contest that's 90 minutes long. It's usually been averaging out to about 20,000 contestants. I think the submission counts that it has on the problems are a little bit off. It's only for when you click the actual submit button. And it doesn't really include the run button's results. I think it'd be more, I'd imagine the run button is still running on their servers rather than in your browser, I'd feel. And we're going to say that it takes about 5 seconds of processing time for submission. I actually looked at some of my own submissions, and a lot of them seem like they'd average out to around 2,000 characters. I think that's a pretty fair number. There's of course going to be some problems that are a lot longer, and some contestants might have much longer, more hacky solutions. So I think averaging it out to about 2,000 characters to a submission is about fair, which would be 2 kilobytes. Any questions before we continue into doing some back of the envelope estimates? All right, we can dive into the numbers then. So how many submissions per second? What's bandwidth required? How many submissions running concurrently? We're going to use the 5-second thing for that. And then I guess that's probably all we need for now. I'll come up with other numbers as we get to them. Yeah, okay. So how many submissions per second? So we have 20,000 contestants, and then we're doing 6 submissions each. That's going to come out to 120,000 submissions total, handled over the course of 90 minutes. So we have 90 minutes times 60 seconds in a minute is to, I actually already did these numbers a little bit in advance, 5,400 seconds total for the contest. And so then we're going to do 120,000 divided by 5,400. It comes out to around 22 submissions per second. So that is our TPS for doing a submission. What's the bandwidth here? So we're doing 22 submissions. It's a TPS of 22. And we have 2 kilobytes per file. So you're uploading this 2,000 kilobyte thing. There'll be some other data in there, like your user ID, maybe some auth information, but the bulk majority of what your bandwidth constraint is going to be defined by the submission file. It's the code you've written and putting it up on the server. So that comes out to 44 kilobytes per second. So you can pretty easily get a 1 gigabit internet connection. I think the EC2 instances for AWS can actually hit about 10 gigabits. And note that's gigabits, not bytes. So I'm going to convert this over to bits instead of bytes. So 44 KB times 8, we're going to round that to 50. So 50 KB times 8 is 400 kilobits per second, which is 0.4 megabits. So that's way less than 1 gigabit, so we are not bandwidth bound. But it would still probably be a good idea to maybe do the pre-signed URLs here. It seems like it's maybe just a good idea to do that. How many submissions running concurrently? So we have 22 submissions per second, and they run for 5 seconds. So we're going to do 22 times 5. That comes out to 110 submissions running concurrently. How many machines would we need for processing those at the same time? How many machines for processing all those current submissions? So we have 110 submissions running currently. And I looked at the numbers for EC2 and just kind of what you're given the number of cores per machine. So an M5.2x large, this seems like it was a really commonly requested size for when you're doing a horizontally scaled service that's being used globally. And we during the contest, they had like 20,000 people from around the world in the Leetcode competition. So I think this is probably fair. It's fair to use the most common. I think this is the most commonly used commodity server size. I don't know if we're going to be using EC2 instances when I draw the diagrams, but we'll go off that. So those have about 8 cores each. Those are actually it's vCPUs, and it's actually only 4 cores. So they're doing like the hyper-threading thing. There's this thing that AMD and Intel introduced where you're able to run like 2 threads at a time, allegedly off the same core. So you're not even getting a full core. And so when you get a M5.2 extra large, you're allegedly able to run 8 threads at the same time off of it. So for one machine, we're just gonna go ahead and round that up to 10. Round up to 10 threads at once. So you're definitely not going to be getting 10 full threads at the same time, and it's virtual threads. We're just going to go ahead and use that number for now, though. So that would come out to about 11 machines for running it at the same time. So that's a fair, I mean, that's not like a huge amount, but I mean, that's a pretty fair amount. It's enough that you might want to, maybe there's some tricks we can do for making it async. I'll kind of show what I want to do when we get into the diagrams and what I'm thinking here. Any questions before we move on to the diagrams, though? All right, let's go ahead and hop into it then. So we're going to have the browser for a contestant that has a problem loaded. So browser for contestant viewing a problem, and they're going to do a submission for it. So I'm going to have it load up into their, oops, on. Okay, so we're going to have, let's say, the problem backend server. Problem backend server. Going to pull it off of, let's say, a problem database. we'll have a problem data store. It's the problem metadata. The problems themselves are going to be like a prompt. So there'll be a object store for that. So you're going to have this. You're going to have, this is a data flow arrow. It's really going to be the server making a request to that. So it's going to look kind of like that. And this will then give you the link to the CDN where the prompt is hosted. So we're going to have a CDN for hosting the problem. Oops. Problem prompt hosted on CDN. That. Move that down a bit. So then you're going to pull it down from the CDN. So now you've got the problem loaded up in your browser. We're going to go ahead and deep dive into this a little bit more later. I think there's a little bit more that I can add for detail on that end, but now you've got the problem loaded up in your browser and you want to do a submission. So you're going to do a submission to, you're going to have the submission backend server. Submission backend server. Okay, so you're going to make a request out to it, and then you're going, so you want to submit that 2 kilobyte file. I think you should probably be doing pre-signed URLs with S3. So you're going to make the request, it'll return back a pre-signed URL, and then you are going to add the file into the S3 bucket. So this is going to be the submission object store. Come on. There we go. So you make the request. Hey, here's the URL, the pre-signed URL. Go upload it to there. There you go. You finish uploading. It returns back, and you send an ACK to the submission backend server saying, "Hey, I'm done uploading it. It's up at that URL you gave me. Go do your thing." And then we want to do some processing of the problem. I think that should be put async. So it's a 5-second processing time. And what if it like screws up and needs to do a retry or something? So it's going to be doing a longer process on the server, and it'd be better if I think it's done asynchronously. So I think it should, I'm going to add on a message broker. I don't think I like, you know what, I'm going to go ahead and use this tube. I'm not the biggest fan of it, but I'm going to have that. So the request comes in, you've got your ACK, you're going to say, hey, I'm done uploading it. And then it's going to put that onto the broker for processing and immediately return back a 200 success. And so then it's going to be in this broker. This is going to be a lot like the pub sub for proximity service, or for chat applications like Discord or WhatsApp, is you send it to the server, it sticks it on the broker, and then immediately returns back a success. So you're going to get this spinning wheel until it's done doing the processing. So we're going to have these task runners that are actually going to run the unit tests. So it's going to be the submission evaluation task runners. And these are going to pull it off of the broker. So the data flow arrow from the broker to here. It's going to do the evaluation, and then eventually we are going to have it. You're going to have WebSockets for handling the processing. Otherwise, you'd be doing polling to see when it's done processing that thing that it takes 5 seconds to do. So instead, we're going to set up a WebSocket over here. And then when it's done doing the actual evaluation over here, it's going to push the result over to here. It's going to call this. And then that is going to, it'll then do a server-side event back to the browser. So I think I looked at Jeff Dean's numbers a little bit. I think a within data center call should take, it's like half a millisecond. I don't know how realistic that is. I think it's like reading off disk is probably going to be the bottleneck. I've actually never seen a within data center call that took less than like 50 milliseconds. Maybe even not, I think like a couple hundred milliseconds is probably the smallest I've ever seen. So let's say that we can maybe get like 100 milliseconds when we've made that async, because we're literally just going to put it off onto the broker. Then over here, we've just got the call over here. We're just going to push it over there, and that's the only processing it's going to handle there. Let me go over this data flow again for what happens following the evaluation completing. So the evaluation completes over here. It calls this to push it over to there. And so then we're going to have a server side push. Okay. And let's say it's 100 milliseconds to get it onto this and 100 milliseconds to get it back. So we could say 200 milliseconds total, as opposed to 5 whole seconds. So then that is 25x less time spent on the server. This would still need to be like the equivalent to 11 machines. I'm thinking Lambda functions over here. I like having it scaled out and made async over here, but there's no need for us to have that many machines over here on the back end as we have over here. So it would make a lot more sense to make this async, and that'd bring us down from 11 on both of these to this would be brought down to 25x less time. So then it would be you're not going to need 11 machines for that amount of time on the server. It would take you only need at most 1 machine for the submission backend server, because it's going to be 25x time less on the server, and we had 11 machines before. So it was 11 machines for the, this is going to be Lambda functions, but again, that's like this is 11 machines equivalent of processing time and powers what's running on these task runners. For submission evaluation task runners, and then it's 25x less for the backend, so it's at most 1. You're probably still going to want to have some machines close to the users. So like it's globally distributed user base. So you're probably going to have more than 1 machine, but you probably don't need to use m5.2x large. You could probably use a m5.large or something, and just have, actually, let's maybe calculate the number of cores that we're still going to need. Is that we had 110 was the need. We needed 110 cores before. So 110 threads, and then we're going to do divided by 25 because it's 25x less time on the servers that we would need. So that brings us to 5 threads, right? Yeah, 5 threads running concurrently on average for this piece. So that one's going to need 5 threads. This one needs 110 for concurrent processing. And so an m5.large is 2 cores. So that would be 3 machines of m5.large. So you could stick 1 in US East, 1 in US West. You could stick 1 in Europe, maybe 1 over in China, something like that. Maybe even go for m4.medium and stick like 2 in each region just for redundancy. That was like a common rule of thumb when I was at Amazon retail, was that you calculate the scale that you need, and then you actually take that machine, and then it's n+1 is how many that you actually have running in each region. So that way, if one of the nodes is faulty for whatever reason, you still have a backup. So I just put in each region 2 machines of m5.large or m5.medium in each region for the submission backend server. That should work pretty well. And then again, Lambda functions, it still is a good idea, I think, to calculate how many machines you'd have if it was like workers, dedicated EC2 instances, just to kind of figure out how you're bound there. And it's definitely compute bound. This is actually going to pull off more than just the broker. It still needs a bit more information than just what we're going to be putting onto the broker. We're also going to pull in some unit tests for, you need to pull in the submission itself. You do need to pull in the submission itself. Let's think about what else we're storing here. Is there's the metadata, but this database is just kind of like it's not an object store, so that the whole prompt is kind of a bigger object. You can have that on the CDN. I think usually you also have that on an actual object store. So let's go ahead and have a problem object store. So this is for like the prompt and the unit test files for a problem. Problem object store. Okay. And those are also going to be, you can have a pull CDN or a push CDN. I don't really want to focus on that for this problem. It's not really the interesting aspect. So we have the problem object store, and this is going to have both the prompt and the unit tests for a given problem. I'm going to pull those unit tests over to here. Okay, so that is the submission part. We also have the ranking part, which runs all the way at the end of the contest. So we have the submissions over here. We're storing, oh, that's right. So it evaluates the problem, and then it needs to store whether or not you're passing before it does the return back here and pushes the results back to your browser for how you did. So that would need another data store. So we're going to need, let's call it the results metadata store. Okay. So we're going to write whether or not a solution is actually passing or failing over to this before we return back to the browser with how you did. We want to persist it and then return it back. Okay, and then we also have the actual ranking occurring at the end. That is going to be a MapReduce job. We're going to run on top of this. I'm feeling event sourcing for this, and I'm going to have Cassandra on this, which would play nicely with a MapReduce job. So we want to have a MapReduce job running on top of that at the end. And it is the ranking MapReduce job. And we're going to spit that out to a leaderboard database. And you can have a browser for a contestant viewing the results of the contest. And then you would have like the leaderboard display backend service. Can't have the browser talking directly to the database, of course. It's going to have this MapReduce job. It's going to pull off of Cassandra, and it's going to spit the results out to the leaderboard DB. We're definitely going to want to talk about the schema for some of these DBs, and maybe talk about my choice a bit more after we get the whole thing end to end. So you're going to be able to see how you did. Then there's the ELO rankings, and you actually see your user like rank like adjusted on your file. There's like your ranking within the contest, and then like if you go on the user pages, there's like a global rank that spans like it's adjusted contest to contest. So that, I think that would be like another, I see that adjusted on like Wednesday from the Leetcode competitions. This one comes out, this like runs like at midnight following the contest. And then this one happens on Wednesday is usually when I see like my contest ranking adjust. You need to pull in from there. you're going to have the users DB, user info DB. And you'd pull in your ranking, your global ranking beforehand. You'd pull in the ELO ranking of how you actually did. So this is for determining how you were expected to do. This is how you actually did. And it pulls in both of those, comes up with a result, and then it adjusts your ELO ranking on your user thing. And so you can have browser for the user page, viewing user page. You'll have like a user backend service, page display service. There we go. Now pull from here. So then when you're viewing your actual user page, that would come off of this where it has your actual global ranking. Let's definitely go into talking about the DB, the DB schemas. Any questions before we do that? Okay, let's dive in. Let's start with submission. The results metadata store. So this is where you're actually recording the pass and fail. So you submit your problem, you upload the actual code over here, send an ACK over here, goes on broker. You have the evaluation running the unit tests. The unit tests are pulled off here. Your code is pulled from here. And then it runs those unit tests against your code, result written to over here, schema. So you're going to want a timestamp for sure. That's one of the components in the rankings afterwards. So you need the timestamp. That's roughly the current Unix epoch time. I finally looked around. I was like, how accurate are those numbers I've been writing down for the timestamps? And this is closer to what today's Unix epoch time is. We're going to want to have the user ID. Who made the submissions? We'll say your user number 123,000. I like the idea of having a submission UUID. CF, 3, DF, ABC. And then we would want the S3 link. So when you're going through the results at the end, you're also able to see the submissions of the top users. Where are those coming from? I'd feel an S3 link for that submission would make sense. // S3 US 2 time taken to complete. I don't know if it really I feel like when it's running the unit tests that it's kind of, it has like a timeout set there. I don't know if you're able to see the time it takes the users to submit. I mean, that does kind of make sense. I feel like that's a component of the unit tests themselves. That is a good consideration, is that I feel like that would come with the timeout you set on the problems in the unit tests. It's like a unit testing criteria. Feel free to call me out if you don't agree with that. I think that's a fair alternative approach, though. So we'll have submission bucket / just use like submission. Oops. We'll just have like the submission UUID. That's where you're actually putting it. S3 link. Oh, you want whether or not it's actually passing or not. So we'll have is passing. And we'll have it's either true or false. And we'll say for this one, true. That's the results metadata store. I actually kind of want to drag that whole bucket over to the right. So that way it's right next to the schema and there's not any room for ambiguity if you guys are looking at this afterwards. There we go. Submission, results, schema, leaderboard, DB. So you're gonna have this MapReduce job. You are gonna have a couple of steps to it. I think so. You're going to want to find timestamps for first passing result of each user for each problem. That's a reduce operation. So you would be looking for find timestamp with least value. So it's not just like summing up or counting. You can also have a reduce operation that's like find least value for a given thing. And so after you've done that, you're also going to count up the number of failed. I feel like it doesn't count failed submissions that occur after a succeeding one. Then again, why would you continue submitting after you get a passing result? Sometimes it's kind of fun to toy around and do a little bit of code golf if you have extra time and you've already completed everything, or you're stuck on the last one and you know you're not going to get it. But I feel like you would just want to count up the failed submissions from prior to first passing result timestamp. And then, so you got that, and then you would want to sort all the users. Scored, and then by order of timestamp with failure penalty. So there's kind of like 3 different MapReduce. You have to do like kind of 3 jobs in a row in order to make the leaderboard. Let's talk about the schema of the leaderboard itself. I kind of want to pull that over to, no, you know what? I'm just going to leave it where it is. Board schema. So you will have the user ID. That's your user number 123,000 out of all of their users on the site. You'll have your rank. So you got placed 2,300 out of 20,000 users that participated. And then you'll have your submissions details. So let's look at one object. For the successful submission link. And that's 3 bucket. Fail count. So user could fail, let's say, 3 times at a problem. Some I've definitely seen, if you crawl far down the leaderboard or within a certain points ranking, some people will literally just spam a submission. You'll see a count of like 12 or something. Yeah, it's mainly just the first page where you only see 0 or 1 fails. And then the success timestamp, first success timestamp. Just like 167 5,000. All right, I think that's all we need over there. And then the user info, it's sure. So we have the user ID. We can say could have a list of, it does have each of your contest ranks. So we could have contest ranks, and we'd have Contest D, contest number 160, contest rank 2300. And then there's the global rank, which is the output of the ELO. Global rank, there's actually a lot on there. Yeah, we could say you're ranked 25,000 globally. There's a lot of dead users, as maybe the term, stale users, dead accounts, just accounts that are not active, inactive accounts. Yeah, okay. I mean, there's a bunch of other info on user schema, but I mean, that's all that we care about that's relevant. What else do we want? Problem metadata store. Problem metadata store. Okay. I'm also going to talk about the indices for these. So you would have the problem, these something like 2300, and then it would have the location of the prompt, and it also have the unit tests. It might make sense to keep those. I feel like there's something you can do to probably speed up the retrieval from the task runners of those. It might even make sense to just have the task runners as dedicated workers that's not repeatedly pulling over the same thing every single time. I mean, there's a couple of options for trying to speed this up a little bit and reducing redundant bandwidth operations or something. Or, you know, that might also add a whole bunch of complexity, so you might even just drop it. So I mean, this would be maybe the least complex approach, is just to have them on the object store and not trying to have dedicated workers set up. And I mean, this would be the primary key, would just be that. And you can just use it as purely the partitioning key. You don't have to specify, oh, what kind of technology am I expecting on this? This would be a fair call for DynamoDB, would maybe be a nice technology for this. It's going to be a little bit read heavy. You definitely can get away with eventual consistency just fine on this. A few hundred milliseconds of latency for the staleness on the reads is probably perfectly fine. You could probably even, you might want to have caches or something like that. Well, so the prompts themselves are going to probably be cached on the CDN. But yeah, it might even make sense to have Redis caching this stuff as well. Okay, let's look at this one. How do we want to do this? We definitely want an index on the user ID as well, because you want to look up yourself and how you did. So it's like when you're looking at the first page of the leaderboard, you're able to look up the first passing submission of like each of the users. I mean, how you're only going to have like a dozen submissions or 24 at most from a user, I think, unless somebody's like absolutely spamming it. I feel like that's kind of like malicious behavior. So I don't think you need to like index anything else like this, or even specifically pull like notes on one of the records if it's their first passing submission. I think you might want to, but it makes sense to have this as part of the index. You might look up by that. It might make sense. Jeez. You're not going to have a celebrity issue on this. You're not going to have a celebrity issue on this. Okay. You won't have a celebrity issue. Do we really want to index this? I can't imagine it's going to hurt. I don't know what specifically you would do to, you might look up your past submissions for a problem, and it's like outside of the contest. I mean, I guess it might make sense to have that indexed. Otherwise, if you don't index it and you're looking up a specific submission, that would take a really long time. The timestamp isn't going to make sense. You're just going to do a MapReduce job. You don't need to look up specifically by timestamp. I don't think that would really make sense. I think that's all we need there. What kind of database? So I was feeling Cassandra on it just because it integrates so well with the MapReduce job from what I've read. Eventual consistency should be fine. So Cassandra, yeah. And we're just doing an event sourcing approach. Leaderboard schema. Okay. You're gonna do some writes, and then I think you can do Cassandra here too. I think you can do Cassandra there. You might be able to do that. I feel like you're not going to, you're just going to kind of write it once. You really need to, you might have a celebrity issue with the first page for like the top ranking ones, but I mean, you would maybe just throw a Redis cache in front of that, maybe have a Redis cache as well that this thing would be checking. How are we going to, what are the indexes going to be? What are the indexes going to be? That's going to be an index. You're going to want to index that. And you will want to, you should have contest ID. Like number 160. You probably want that indexed. And then what's the partition key? Well, you're going to have, this is going, your most recent contest is going to be the one that's going to be looked at the most. And so you can get a hot partition there. And so you would probably want to have that one evenly distributed across the partitions. So how can you do that? You don't want, okay. That would be a sort key. So this would be a sort key. It's a secondary index. Okay, rank. You definitely need that indexed. You don't want that as the partition key either, because then the top, it's always going to have the most popular ones at the top. You want consistent hashing. Well, the contest is paginated. Actually, the contest is paginated. So then you don't want scatter gather. Okay, you might actually want this as the partition key, actually. And then you would maybe use Redis to make sure that you don't get absolutely destroyed by a celebrity issue. So I think you would maybe want to have this as the partition key, actually. You will get a hot partition key and you just remedy it with Redis. And then that is a very important sort key right there. You don't want scatter gather over the network. Okay. I think I'm pretty happy with that. User info. This is kind of like a supplemental piece of this design. It's not really the focus of our design. You know what, let's go ahead and deep dive it anyways. Would we want to partition by that? I mean, you could get, again, celebrity issue, you know, everyone's gonna be looking at, there's that user UWI or something who always scores in like the top 20 every single contest. I'm sure he gets plenty of views on his profile. Is it enough that it would warrant being, would it really be a hot partition issue? Well, so there's other ones. So I think you would want, so this would be the partitioning key. You would use that as a partitioning key, and you would have it, you wouldn't have it as a sort key too. You would want to have UWI should be on a different partition than like the guy immediately above and below him. So it would be a partitioning key, but you don't have all the most highly ranked ones all the way at the top. So this one would be the sort key. Global rank, you could have that as the sort key. So then you don't have really a hot partition issue so much because there's multiple celebrities and they all are on different partitions. So that's fine. So we'll say celebrities on different partitions. Yeah, so then that's fine. You don't even need to get away with a Redis thing for trying to handle the hot partition issue. Leaderboard, yeah, I don't think people are spamming the leaderboard hard enough that we need to worry about that. And again, Redis will help us. If not, pretty happy with a lot of this. Yeah, we already did estimates on this and on this. Yeah, all right. I think I'm pretty happy with this. We can probably call it a day. Any questions before we wrap it up? All right, I think I've handled everything I wanted. Thanks for joining, guys. I'll see you next time. Have a wonderful night.
Mike, one question, Mike.
Sure. Yeah, what's up?
Is there a read somewhere for this, like how to design such kind of platform? I mean, does Alex or someone cover this problem?
Oh, does anyone else cover this problem? Is that what you're asking?
Yeah.
Okay. I did see a couple of other YouTube videos on it online.
Okay.
I think Gaurav Sen also covered this problem. There was a couple of other YouTube videos on it. I don't know if they went as extensive on it as I did. Most people don't really cover capacity estimates. This is recorded, by the way, and I'll upload it to YouTube. So you'll be able to review it just fine. And I'm going to post the diagram and the text file into a thread in the Discord channel. I'll post it into the forum discussion one. So you'll be able to access it later. And again, there's a couple of other YouTubers that covered this problem. Gaurav Sen definitely covered it, I think.
Thank you.
Okay. Does that help with your question? Is there anything else? Were you asking for generally how to handle this problem, or?
Yeah, it was more like a general question.
Okay.
I'm probably looking for some reference to read.
So it was kind of similar to, it's a little bit like designing the problem for, what is it? Job scheduler, because you're kind of doing jobs over here. It's a little bit inspired by how the job scheduler problem is handled. And then there's the leaderboard problem from Alex Shu. Oh, I didn't even go over how to do it live. Okay. Add click aggregator is also kind of similar to what I'm kind of doing here with this piece with the leaderboard.
I see.
I would recommend checking out Alex Shu's books. Yeah. So Alex Shu's books generally have a lot of similar patterns. So I think add click aggregator has some similarities. Yeah, there's one way you can do this with MapReduce, I think. What else had MapReduce in it? I know he had something else in his books that had MapReduce. In the glossary for book 2, you can look for the word MapReduce and it'll have some other stuff that used MapReduce. Yeah, I like Alex Shu's books a lot. And then I also like DDIA a lot. If you're going to get a physical copy of any book, I would recommend Signing Data Intensive Applications by Martin Kleppman. Spelled kind of like that. I might have misspelled his name.
I think these are correct.
Okay. I'd recommend those materials the most. Yeah, all right. How helpful is that? Is there anything specifically you'd like me to dive into?
No, I think it makes sense. I mean, it's good.
For the broker, that's actually similar to the WhatsApp design. So I think maybe it was Alex Chu's first book had the design for WhatsApp, or what was Discord. So you'll have this thing where it has WebSockets off of this connecting to this, and you'll have it's like messaging other users, and it uses like Redis PubSub over here. And so I did something kind of similar to that, but instead of having it push out to a bunch of users, I just have the PubSub. We're doing point to point on this broker instead of PubSub. I think maybe I didn't specify it, but I was like kind of thinking of SQS here. I usually don't recommend SQS, but it's you would use Kafka if you want something that's persisted for hours on end in case there's an outage over here, but you don't want to see the results of the submission hours after you clicked the submit button. So that's why I think SQS would actually maybe make sense here. I haven't read up a ton on Redis PubSub, but that's another thing that is commonly used in something with WebSockets. I don't know if it can be set up for point to point though. Yeah, this is another good one for what I'm doing in this little chunk right here. Okay. Any questions about anything specific with this that I can help with?
It looks good. So due to daylight savings coming in place, and is this that going to be the time I joined after a couple of weeks?
I'm probably gonna have it start at 9 p.m. from now on. If the Leetcode competitions stick to 6:30 going forward, I'm definitely not gonna be able to start these at 6 p.m. anymore because I like to participate in the Leetcode competitions. And I cannot allow this to conflict with the Leetcode competitions. So I'm gonna check when the one is for next week. Maybe it was just like a one-off issue or something. But it's looking likely that I'm probably gonna bump this to 9 p.m. usually every week. Yeah.
Should be fine. Thank you.
Yeah. All right. And I'll upload this onto YouTube. Like I said, I'll post the link into the forum discussion thread on Discord. I'll post the diagram as usual and the text file. Yeah. All right. Any questions from anyone before we wrap it up?
No, thanks a lot, Michael. So this is my first time. I just joined a couple of days back. So thanks. I'll go through all the other videos as well. Yeah.
They're all just on my YouTube channel. I'll post a link to that again, just in the general channel, just so you guys can find it pretty easily.
Yeah. Just one quick question. So I'm mostly from systems and I'm pretty new to system design. So in these designs, the scalability and, node failures are already automatically taken care by S3 in this case, is it? Is that the assumption?
Failures on the nodes. Okay, so that was why I have it set up so that this is coming after the brokers, that when you have a broker set up like SQS, it handles retries automatically for you. If you had the retries handled over here, that would mean that if you had it before you return a success to the client, that would mean that the client itself owning the browser would kind of be handling the retries against the backend server, which is bad because then that's like super latent. And so I liked that I just have it stuck onto the broker and returns back real quick, because then it has the 5 to 10 seconds of processing over here behind the broker. Brokers can kind of be thought of as a data store. I think that was somewhere in Martin Kleppman's book, is that brokers can kind of be considered a data store. Kafka in particular can really be considered, it's basically a data store. And so then you just have this message, and it's going to keep retrying this until it's properly processed off the broker. And that's hidden behind a persistence layer. And so the browser's not really getting exposed to that. Where else are we kind of Yeah, so it's anything that happens after one of your internal data stores is going to have the retries will work pretty cleanly. Yeah,
Okay.
it's okay. Is there any part in particular you're interested in seeing the failure scenarios for?
No, I just wanted to kind of know in general because some of the, so I'm just starting with some system design right now. So I saw that there'll be load balancers and the node failures will be kind of taken care of. So that's why I had this question, but I'll again go through this video and if needed, I'll ask on the channel. Thanks.
Okay. I have a horrible habit of forgetting to add load balancers to my designs, by the way. When I was at Amazon, we had all these diagrams for our internal services, and we never really specified that we would have a load balancer, but whenever I mark server, that means that it's horizontally scaled and it will usually have a load balancer in front of it.
Okay.
Yeah, I have a horrible habit of just totally leaving those out. I think that in Google for their system design interviews, they really like you to clarify whether you want like a L5 or L7 load balancer and whether it's a reverse proxy or whether it's like a proper hardware load balancer.
Okay.
But at Amazon, you're just able to throw in an elastic load balancer at something and like call it a day. And it's usually very hidden from us as engineers. It was like you just have this little thing you click once and then you forget about it for years on end. And so now I have that habit of completely forgetting about having load balancers in my diagrams.
Okay, sure. Thank you.
Okay. Any other questions from anybody? I'd be happy to answer anything. Okay, I can actually go ahead and pull up my YouTube channel is at C, and that's where I have, I'll just post it in the general right now. And it's where I've recorded the ones from previous weeks. And if you just go to videos, it should be sorted by week just normally. Yeah. Okay. Any last questions or can I wrap it up?
Thanks, Mike. Thanks, everyone.
All right, cool. I'll let you guys go. Have a wonderful night. Thanks for joining. I'll see you guys next time.
Bye.